हेलो स्टूडेंट्स, हाउ आर यू? कैसी तैयारी चल रही है? वेलकम टू माय यूट्यूब चैनल. टुडे आई शैल डिस्कस मोर अबाउट solid state. Today I shall consider the number of atoms in a unit cell. How we can calculate the number of atoms present in a particular unit cell. We know that each crystal lattice is made up of number of unit cells. Each crystal lattice consists of number of unit cells, and each lattice point there is a constituent particle. This constituent particle may be atom, molecule or ion at each lattice point. Now we, for simplicity, we shall take atom as a constituent particle and we shall consider the cubic unit cell. We know that in case of cubic unit cell, there may be three types of structures: primitive cubic unit cell, face-centered cubic unit cell, and body-centered cubic unit cell. First, I shall take the case of primitive cubic unit cell. In case of primitive cubic unit cell, the constituent particles or atoms are present only at the corner positions. Atoms are present only at the corner position. Since there are 8 corners, therefore the atoms are present at the 8 corners. Here we represent the atoms by a small sphere which is not the actual size of atom. This structure is known as open structure. This structure is called open structure. Now in a crystal lattice we can easily see that each corner atom is shared by 8 neighboring unit cells. Therefore the contribution of each atom to a particular unit cell is 1 by 8. Therefore contribution of each corner atom to particular unit cell is 1 by 8. Is 1 by 8. Since there are 8 corners, therefore 8 into 1 by 8, 1 atom. The contribution of corner atoms is 1 by 8, and there are 8 corners, therefore there is 1 atom. Since the atoms are present only at the corner position, therefore the total number of atoms per unit cell is 1 atom. In case of primitive cubic unit cell. Now take the case of face-centered cubic unit cell. In case of face-centered cubic unit cells, besides the 8 corners, atoms are also present at the center of 6 faces. Therefore, first we shall calculate the contribution of corner atoms. Since there are 8 corners and each corner atom is shared by 8 unit cells, therefore 8 into 1 by 8, it is 1 atom. The contribution of corner atoms to a particular unit cell is 1 atom. Now the atom present at each face is shared by 2 unit cells. Is shared by 2 unit cells. This unit cell and neighboring unit cell. Therefore the contribution of face-centered atom to a particular unit cell is 1 by 2. Since there are 6 faces, therefore the total atoms will be 6 into 1 by 2, 3 atoms. The contribution of face-centered atoms to a particular unit cell is 3 atoms. Therefore the total number of atoms is 1 plus 3, it is 4 atoms. There it is 4 atoms per unit cell. Total number of atoms per unit cell in case of face-centered unit cell is 4 atoms. The last is body-centered unit cell. In case of body-centered unit cell, besides corners, there is 1 atom present inside the cell. Therefore, the contribution of corner atoms is 8 into 1 by 8. It comes 1, and inside the atom present inside the unit cell is not shared by any unit cell, therefore its contribution is 1. Therefore the total total number of atoms per unit cell is 1 plus 1 is equal to 2 atoms. Thus we see that in case of primitive cubic unit cell, the total number of atoms per unit cell is 1 atom. Since atom present at each corner is shared by 8 neighboring unit cells, therefore its contribution is 1 by 8. 8 multiplied by 1 by 8 is 1 atom. In case of face-centered cubic unit cell, there are two types of atoms. Atoms present at the corners and atoms present at 6 faces. The contribution of atoms present at the corners is 8 into 1 by 8. It is equal to 1 atom per unit cell. And those present at 6 faces is 6 into 1 by 2 is equal to 3 atom. Since each atom present at the face is shared by 2 unit cells. Therefore total number of atoms is 1 plus 3 is equal to 4 atoms. This is the total atoms per unit cell in case of face-centered cubic unit cell. In case of body-centered cubic unit cell, there are atoms present at 8 corners. Their contribution is 8 into 1 by 8 is equal to 1 atom, and 1 atom is present inside the unit cell which is not shared by any other neighboring unit cell. Therefore its contribution is 1. Therefore total number of atoms is 1 plus 1 is equal to 2 atoms. These calculations will help in the calculation of density of unit cell. When we consider the density of unit cell, then we have to know the number of atoms present in a unit cell. These data will be useful in calculation of density of unit cell. If you have any doubt in this lecture, you can write in the comment box. Thank you for watching my channel. Your comments are welcome. You can suggest me any other topic you want to discuss on later. Thank you once again.